class materials. So what we have covered last class is the function, not the basics, but we already have done those things, modularity and composition. In addition to that, we have covered helper function and inner function. Today, I'll discuss about the scope. In addition to that, I'll be discussing the higher order functions. First, discuss about the scope. What is a scope? The scope is the most important area of programming because it determines where a variable can be accessed or used. If, like, for example, you are defining a variable inside a function, can you use it outside of the function? Or if you'd like to use a variable that is defined outside of the function, can you use it inside of the function? Or maybe in an inner function, how can you use those inner variables? This is like a usability. Now, if you'd like to modify it, can you modify a global variable inside a function? Like, you can always use a global variable inside a function, but can you modify it? Same thing for the enclosed one. If it is like an inner function, the outer function variable can be accessed through the inner function. Can you modify it? For example, like this x1, y1, x2, y2. They are coming from the outer function area. Now, in that particular function, can you modify the x1 to 10 instead of whatever the value? So for those particular reasons, we need to know what are the scopes. So basically, scope is a set of rules to determine whether a variable can be used, and it has like 4 resolution, scope resolution in Python, which is like LEGB. L stands for local, E stands for enclosed, G stands for global, and B stands for built-in. Okay. So local, whenever we are defining a function, the variables are local. Whenever we are creating a block of code, so function is nothing but a block of code, right? What are the other block of codes you have used other than function? A conditional, a block of code, or maybe opening a file with, right? It's a block of code. So block of code, whenever you are defining a variable inside a block of code, those particular variables scope is under that particular block. You cannot access that particular variable outside of the block. Okay. So like typically we are using local variable in function. Whenever we're defining a function, those variables are declared at the very first line, and you cannot access those variables after the end of the function. That means whenever the function block ends, the scope is done for that particular variable. And this type of variable scope typically called is like local scope. Same thing for other function. Those particular variables is for that particular function. You cannot access those particular variable to other function or as a global way. To solve this problem, we need to write a variable as a global so that we can use that particular variable throughout the program. And that particular variable is called like a global. And whenever you are defining a global variable, that shouldn't be under any block. Just like our import. So for last few projects, I told you do not use any global code. That means I discouraged you to not use a global variable. I encourage you to use a local variable in the function so that you can use the function parameter and the local variable passing. So global variable, whenever you're declaring a variable outside of function or outside of any block, this is not under any block, this is a global. You can access that particular variable throughout the program in any function, in any block, or globally. This is for the global scope. Enclosed is like if your function, your variable, like for example, this particular one, we have an enclosed variable of x1. We haven't defined the x1 here in the radius function, but we can use that x1 from here. It's like a global for that particular method or function, but it is not outside. You cannot use the x1 outside of the function. You cannot use it. You'll have an error. That's because the scope of this x1 is not a global. So for that particular one, in our function, this x1 has the capability to find the value from the outer function. This is particularly called the enclosed scope of that particular variable. Now, what is the built-in type? The built-in type, what I think Lucas told in the last class about the pi, instead of 3.14, we can use a variable called like pi, a global variable. And for that global variable, import math. So math.pi. We can use math.pi. It's like a variable from the math function. So instead of 3.14, we can use math.pi. Now, instead of not writing math, we can rewrite this code like from math, import all or import math, import pi, so that I don't need to use the math.pi, just the pi. Okay. Now the question is, this particular value, let me find the value of pi. Okay, that means I'm not writing and like calling any function right now. I'm just printing the pi value, or what I can do, I can just write the comment. It is a long number, 3.1415926535, blah, blah, blah. Now, I would like to use that particular variable in different way. For example, I can use a pi value to 3.141592. Okay. I can use another pi variable here, 3.1416. I can use another variable pi, 3.14. I have like 3 variables here. Actually 4. This pi is a global variable. This pi is a local variable, not exactly local. So this one is local. So this one is local for radius. And this pi is local for area. So for this particular radius, this pi is an enclosed variable. Now, if I use a pi here, which one it will print? Under the radius, I am printing pi. I have 4 pi's. One here as a local, another here as enclosed, another here as a global, and then the last one is here like a built-in. And I'm printing pi. What do you think? Local one. The local one? Okay. The local one is 3.14, like 2 digit. The enclosed one is 4 digit. And The global one is 6 digit and the built-in one is like more digit. I don't know how many digits are there. It is getting the built-in one. Now, given that I don't have any built-in,
You haven't called area.
what's that?
You haven't called.
Oh,
the
I haven't
function.
called. Okay. So it's a good one. I haven't called it. Okay. Let me call and see what it will return. Yeah, the same. If we don't have any built-in, oh, I haven't called the radius. So it called area, but this particular inner function is not yet called.
That one I did not catch.
Yeah, it's a good one. Let me read on this code again with the built-in one. Again, for the built-in, I print the built-in. This to print pi. Oh, okay. You're right. Go to the local. Then I don't have the local. Then what it will print? Global one, enclosed one, or the built-in one. So it goes that hierarchy. So first start with local. If it is not there, looking for that variable, whether it is in the enclosed. Yes, in the enclosed, it prints. If it is not in the enclosed, then it will looking for that particular variable as a global scope. If it is there, print that. If it is not in the global one, then it takes that value from the built-in one. So this is the hierarchy: local, enclosed, global, and built-in. That's why LEGB. Local first, enclosed, then global, then built-in. And if it is not in the built-in, probably then you'll have an error. Okay. Now that can be a trickier question for your exam as well. Like if I give you this type of code and I ask you what it will print, you need to know the hierarchy of this rule. First local, if it's not there, looking for this particular things in enclosed. If it's not there, looking for these things as a global. If it's not there, looking for the last search from the built-in. If it's not done, then there's an error. Like if I print here like py, well, there's an error. This py is not either local or enclosed or global. And this py is like a smaller case, not capital case. But the good thing is, like by convention, whenever we are defining any global variable, it is like all capitalized. So that is make sure that it is a global variable. Okay. Now the question is, well, I have a global variable here, not the pi, maybe sales tax, for example. Sales tax. It is like 8.25%. It's like a sales tax. Now, maybe I'm calculating a sales tax for a different state, and that sales tax can be altered. I don't need to use the 8.25% for all of my states. How I can modify these things for that particular state? Can I modify a global variable in local scope? No. By default, no. But there are some ways to do that. The ways are, you need to define as a global. You need to define as a global. Now, what happened if you are just writing S tax is 7 point, or maybe this one 0.0725%. At some point, so typically this type of problem occurs whenever you have a counter. It's better to you write a situation with the counter. So counter is 0. And what you are doing, you are starting the counter from 100, not from 0, maybe from 100 at here. And in that particular function, what you are doing, you are incrementing by 1. So the first question is like, what is the value of counter? So the counter value was 0 as a global scope. In the local scope, you are modifying the counter to 100. So this counter is looking for actually which one? This one and that one. Well, the first one is the inner. There is no inner one, like local one. If there is no local, it goes to the enclosed. We have an enclosed one, 100. So it is increased by 101. It will print 101. Now, after calling the function, if I print the counter, what do you think? What it will print? 101. Make it simple. So this is our code. So counter defined as a global scope. Now I'm modifying that counter to 100 in the local scope for the area. And then in the radius, I'm incrementing by 1. Well, with that operation, this counter, what is this counter? It is looking for the inner. We don't have an inner. If we have an inner, probably it will take 1001. If it is not there, then it will go upward, enclosed. There is an enclosed, 100. It will increment by 1, 101. Right? Then, if it is not there, for example, then it will take the global one, 0 plus 1 counter. But my question is, my goal is to modify the counter. So previously in the global scope, I have a 0, but at some point I would like to modify this counter to 100. Now, it should add with 100 plus 1, it is fine totally. But after calling the function, what is the value of this counter? 101 or 0 or 100? So there are 3 options. What is the value of this counter? 0, 100, 101. So mostly 100 is not a good answer. You can skip it. The 2 options now. 0 or 101. Or 1, maybe the 4th option. 0, 1, 100, 101. Equal probability. Roman?
Oh, you're calling it inside the area function, so I think it's going to return.
100. Okay. So 100 for Roman. How many are with Roman?
We aren't printing the area function.
Oh, okay. Actually, it should be. Sorry, my bad. Yeah, this is the right one.
You don't have to change my answer.
Okay. Roman is going to change his answer.
That return 0.
Then 0. Okay. The followers are still with Roman.
He's going to print 101 twice.
101 twice. Well, yeah, definitely there is a 100 here, 101 here, twice. Any other? That's 2 options.
The illusion of choice.
Okay. You want to add anything, Gavin?
I don't have anything better. I
Okay.
can't figure out what it's going to do.
Now, first I'll go with Wade. Why you are saying that it will print twice 101?
Because
Yeah, it is fine for this one. Keep the first one. Why it is printing here 101?
Because it is calling area,
Okay, it goes there.
and in area it calls radius. It defines counter to be 100
Mhm.
and then goes to the radius.
Okay,
And then in there, it increments it by a 1, it
Mhm.
prints it. And then after it's done calling area, then it prints it in the global.
okay. What's the logic, Roman? For 0?
The area function isn't going to.
It's not going to the global variable.
We'll alter it.
Okay, so it's not altering. So yeah, Roman's region was when we're calling the area function, it is not doing anything with the global variable counter. That's why it is not changing, and we're getting the 0. Let's run it. Oh, I have an
We
error.
were both wrong.
The secret third option.
Still, what is the problem?
What's it say?
Local access local variable counter where it is not associated with a value.
I guess it was. That was the right answer.
Okay, this is the right answer, definitely. How I can rewrite this code? Well, I'm just rewriting this code in the way I'm not incrementing, but I'm reassigning. Again, I'm reassigning to 1000. So yeah, I'm just changing this variable here. Like instead of adding 1, I'm just assigning to 1000, reassigning. My plan is to modify the global one. So global one will not modify unless you are specifying it like, well, you need to modify it. So if you just run this code in a Python tutor, you'll see there are like 3 different counter variable here. So one for global, for the area function, whenever you call the area function, in that area function, you'll have a counter here. When you're calling a radius calling, there is another one for the radius. Now, when you're printing counter here, one counter is in the radius, another counter is in the area, another counter is in the global. Our goal is to modify the global, but with the same name, we're not modifying. So when you are printing a counter, it is not under any block, it is looking for the global. If you're printing here, it is looking for the local one. That's why it prints 1000. Now, how we can modify, so this is like a scenario. You plan to modify the global variable, but you cannot. In this scenario, how you can solve the problem? To solve the problem, you need to modify here like, well, this is a global. I need to modify the global variable to 1000. You are modifying the global variable counter. You're assuming this counter is not a local variable. You are referring the global variable to here. And then you are modifying that counter to 100. Now the global variable is changed. It will print 100. In that particular case, this counter is not a local one. It is referring the global one. Same thing for the enclosed. So whenever you're talking about the enclosed one, it is basically a local for radius. It is not concerning the upper one. So you need to tell that non-counter as a non-local. So this particular variable is non-local. Now this will work. Now this counter is not a local variable here. It is a non-local. It is looking for the upper one here. If it is not the upper one, it is looking for here. Typically non-local is used on the enclosed version only. Now it will increment by 1. What is the value? 100. So 100 plus 1. Now if you print the counter here after the function call, so this is our function call and definition. So I have a counter, I am printing counter, it will print 100. Now in that particular function, I'm referring a non-local counter to that particular variable and incremented it here. This counter is referring to non-local to here, and after the function call, it has already been modified. Does that make sense? Modifying a variable as local to non-local, like enclosed version, or global variable modification in a local scope. But unfortunately, built-in variable cannot be modified. But there are some ways, like if you use the built-in, for example, len is a function, right? If you're putting len as a 10, there is an example here for the global. Let me see which example. So those are the built-in names. So with that list, if you write the len, it will print the length of this list. But if you're just assigning len as a 10, then this will not work. You cannot modify from the built-in version, but you are reassigning the value to the keyword. That's why the very first day I told you, do not use any variable name, like any keyword name as a variable or a function. Okay. Any question about the scope? Okay. So the last thing is like higher order function. What is the higher order function? Whenever you're calling a function within a function. But in that particular case, you are putting the function name as a parameter. This is called a higher order function. And why do you need to do those things? Whenever we need to do the same thing again and again, like an iterative way, then we can use a higher order function. So most common higher order functions are map, reduce, and filter. In addition to that, there is a specific type of function which is called lambda function. Lambda function is nothing but an anonymous function, like an inline function. So for example, if you're writing a function, if you remember our sorting things. So if we would like to sort by the second item, so this is our list of tuples. So this is lane and the line number, then the lane and the line number. And this is like a lane and the line number. So if you like to sort by their length, line number, it is easy to sort, like sort LT, basically sorted. LT, it will sort by the line number. So 8, 10 will go first, then 10, 100, then 15, 1000. Now, if we'd like to sort by the second number, we have used a variable like key, and we have used a function like sort by second. And that particular function is doing what? So this is like a def, and you are putting a list there and returning the list second item. This is how we have done, right? For sorting the second number. Now you can see here for this particular function, it's just like a single line function. So we can replace this particular type of function in a lambda function or anonymous function. So what is the lambda function? You need to know the syntax first. So lambda function syntax is lambda is a keyword, arguments, colon, expression. In our particular case, I need to write lambda, then so arguments and expression. So what's the argument? This particular one, right? This is the argument. And what's the expression? Expression is not the return one, L1, L2. So we can replace this one with this function call. So this is like a lambda function. Now, if you'd like to add two numbers and return the result, well, the two numbers are x and y, two arguments. And what's the expression? X plus 1, x plus y. So you can write this one as a function, like add is a function, like that. Okay. Any question about the lambda function? Well, we're running out of time, so next class I will start with the higher order function first, and then I will go later. I'm not sure whether we have an assignment with the higher order function. Do we have any? Let's see. Yeah, I told you. So what you can do, you can postpone this one for this week. That will be assigned to the next week, okay? Since I haven't covered the map reduce one yet. Okay. I can share a video for you after the class about the map reduce function, but I'll definitely discuss these things after, like in next class. So you can postpone this one to the next week. So what I'm going to do, I'm postponing to the next week. Okay. Any question? Well, we're running out of time.